Hello friends and welcome at my channel. Today I would like to solve one more extreme value problem. We are having a sheet of paper and we are going to fold it. We're going to cut off an unknown amount of x on each corner, and the idea is to produce out of it a so-called parallelepiped with the biggest volume possible. Let's say this side is 16 centimeters wide, and that would be, for example, 10 centimeters wide. And what we're cutting off is the x value equal everywhere. So I think it's clear. We're cutting it off, and then we're folding it twice. So the height of the parallelepiped is going to be x, and so it should have the biggest volume. Obviously, we're cutting it on both hand sides here and there. So one of the sides is going to be 10 minus 2x. The other side is 16 minus 2x. And the height is x. And this is the volume depending on x. And we would like to have it max. All right, obviously, x cannot get bigger than 5, obviously greater than 0, otherwise we have no volume, if this factor is going to become 0, and otherwise it cannot be bigger than 5, because if that's the case, this value is becoming 0 or even negative if x is getting over 5. So this is our main idea, to maximize this value. And before we start derivating, producing derivatives, let's multiply it out. So v of x would be equal to, let's say, 10x minus 2x squared times 16 minus 2x, and let's multiply it out. We're going to get 160x minus 32x squared minus 20x squared plus 4 x cubed, that's 4x cubed, minus 52x squared plus 160x. I hope I haven't done any mistakes. All right, so the derivative. We got 12x squared minus 104x plus 160. We put it equal to 0. We divided by 12 as well, so we got x squared minus 104 and is divisible by 4. 12 is divisible by 4 as well, so we're going to end up at 26 by 3 x, and if we divide this one by 4, it's going to be 40 divided by 3 equal to 0. x1, 2. This is 13 thirds plus minus square root out of 169 divided by 9 minus 120 divided by 9. That would be 13 divided by 3 plus minus, well, 169 minus 120 is 49. We can take a square root out of 49, which is 7. So we're going to get 7 divided by 3, right? So x1 would be 13 thirds minus 7, which is 6 thirds or 2. And x2 would be 20 thirds, which is, by the way, bigger than 15 thirds. That would be 5. So it's not applicable. We discussed previously it cannot get over 5. So we stick to 2. And what we would like to do, we'd like to figure out the second derivative, v prime, second prime of x. What would that be? Well, that would be 24x minus 104. 24x x minus 104. So v second prime of that value, that's 2, is 24 times 2 is 48 minus 104. So obviously it's less than 0. And 56 minus 56 in order to be precisely correct. So that means we have a max, and that was exactly the idea. So if we have a sheet of paper with 16 and 2 centimeters as measures, and we're cutting off 2 centimeters on each corner and then folding it, it's going to be a parallelepiped like that with the highest volume possible. They didn't ask, or I'm not asking for the volume, but of course we can compute it as well. Since we have the main function, you see that would become 10 minus 4 is 6, 16 minus 4 is 12, so 12 times 6, 72 times 2, 144, well, cubic centimeters, if that would be the idea, if we're talking about centimeters. I told you sheet of paper, so that rather be should be in centimeters. Okay, guys, thanks for watching. I hope it's clear, and I think next time we will do maybe something like this, or we'll start with integrals. See you.